So here is another interesting problem that is given as the following. And the problem is saying that a unity feedback system has the open loop transfer function shown below, and find the steady state error when R of S is a unit step. And we are given open loop transfer function. Okay, so this is open loop transfer function, OLTF, and the R of S equals it's a unit step, and need to find the steady state error when R of S is a unit step. So steady state error ESS equal what? So let's begin with what we know. So given that G of S equals 100 of S plus 4 divided by S squared minus 1. So now what I'm interested is we need to know the closed loop transfer function of this. So recall that uh, E of S equals R of S over 1 plus G of S and H of S. But because this is we're not given the H of S, we can simply get rid of H of S and simply write E of S over R of S equals 1 over 1 plus G of S, which is the closed loop transfer function, CLTF. So let's go ahead and convert this to a closed loop transfer function. So E of S and R of S equals 1 over 1 plus G of S, which is equal to, so 100, 1 over 1 plus 100 S plus 4 over S squared minus 1. So this is my value from G of S. If you can see here, this is my G of S, and I'll substitute G of S for the expression given. So let's go ahead and just do some simple algebra. So I can do 1 over S squared minus 1 plus 100 is plus 400 and divide by S squared minus 1, which is equal to S squared minus 1 over S squared plus 100 S plus 399, because 400 minus 1 is 399. So now that I have ES over RS equals that expression. But the question is asking us to find the steady state error, and recall that the steady state error can be calculated as this. Steady state error is equal to limit S tends to 0 and S of E of S over R of S times R of S. And because R of S is given as the unit step, so that means we will have R of S equals 1 over S, and I have S in here, right? So I can just cancel them and just do the steady state error is equal to the limit S tends to 0 of E of S over R of S. Okay, so that is interesting. So I can simply write S tends to 0 and E of S and R of S is equal to S squared minus 1 over S squared plus 100S plus 399. And if you put the value of S to 0, so what we can see here is this is 0, this is also 0, this is also 0. So I will be left with only -1 divided by 399. So let's go ahead and do that. So -1 over 399 is going to be negative. So let's put that in calculator. So 1 divided by 399 is going to be 0.0025. Okay, so that is my negative value. So therefore, the steady state error equals negative 0.0025. There you have it. The steady state error when R of S is a unit step.